All right, we're going to continue on our journey of adding and subtracting like radicals. Here we are. This seems like a whole bunch of unlike stuff. What we notice is that the radicals, we're going to be adding and subtracting radicals. However, none of the radicands are the same. However, the indexes of my radicals are all the same, so they're all square roots. So perhaps the first thing I'm going to do is I'm going to simplify each term. So I ask myself, does there exist a perfect square that is a factor of 27? And by the way, this negative symbol just means -1 times the root of -27. So that negative sign is going to stick out in front. So yes, there is a perfect square, and the perfect square is that. And 3 times the square root of 5. So I can write this as 3 times the square root of 5. Since 5 is a prime number, I can't pull out a perfect square that's a factor of 5. Now 80. 80 is curious, right? So can I just maybe give us a little bit of sense of intuition? This first term is going to leave us with root 3. The second term is going to leave this with root 5. So I strongly suspect that when I decompose 80, it'll split up into some meaningful number that it's 3 times something or 5 times something. So let's just think, and if I think 80, oh, wow. Did you know that 80 is 16 times 5? Or you can do the prime factorization of it as well. So minus 2. Now the root of 12 really is, well, I think that it's a perfect square as a factor of 12, and that's 4. 4 times 3. So again, if you have a list of your perfect squares in front of you, it really, really does help. I mean, the only best way to sort of get more prepared is actually sort of take a prepared approach to this. So here we are. So I'm just going to write this. Now I better be careful. This last term is a little bit scary to me, and I'll hopefully guide you the right way. So I'm simplifying that first term, simplifying the second term, simplifying the third term, and then I'm going to simplify this last term. Be very, very careful, because here, this radical is being multiplied by 2. And when I simplify the radical, the square root of 4 times 3, that is 2 root 3. Remember, one thought per line as we go along. As I clean this up, not much thinking goes on. I'm just going to copy the terms out as I see them, but I'm going to take extra time in this last term. -2 times 2 root 3 is 4. -4 root 3. Just like polynomials, if I told you -2 times 2x, you would tell me that that's -4x, right? So anyways, I'm just going to combine everything. See that this is like, so these terms are like, these terms are like. Those 2 middle terms are like, so I can combine them. -3 root 3 minus 4 root 3 is going to be -7 root 3. So that's the green term. Now the yellow term is root 5. 3 root 5 minus 4 root 5, well, that's just -1 root 5. And I'm just going to write it as -root 5.